Okay, this is the December meeting of the WEBRTC working group. The group abides by the W3C patent policy at the link below. And only people, companies listed at the link are allowed to make substantive contributions. We're going to cover captured surface switching and code transform, WEBRTC PC, screen sharing, and media capture output today. Here's a list of future meetings from January to April. The slides are up on the wiki. Do we have a volunteer for note-taking?
I'll do it.
Okay, thank you. Thank you, Don. Okay, we have a code of conduct that we operate under. We're all passionate, but let's keep it cordial and professional. I think you all know how to use Google Meet at this point. Raise your hand to get into the queue and lower your hand to get out of it. And please use headphones and state your name, etc. As usual, just because something is in the repo doesn't mean it's been adopted. And so here's the agenda for today. We have a total of 3 big items. And I'm going to hand it over to Tove to do the captured surface switching presentation.
Yes. Hello, everyone. Yeah, so my name is Tove Petersson, and I'm going to talk a bit about surface switching or captured surface switching today. And yeah, you've probably seen this before. So we already have surface switching in both in Chrome, where we can switch between different tabs by using this tab instead if you have an ongoing capture. Mac OS or Apple introduced in Mac OS, I think in last release, a way to also change an active ongoing screen sharing session to something else, to some other window or screen also, I think. What we want to do here now is to provide some better API support for web applications to kind of be notified by that this is happening and be able to react to this when we change one surface to another. And also expand this functionality, be able to expand this functionality to also allow switching between different types of surface switching, between, for instance, a tab and or a window, and so on. Next slide, please. So there are 2 issues that I will be talking about today, and the bulk of the time we will spend on the first one, which is auto pause for capture surface switching, and then I have a small one at the end of cross-tab surface switching if we have time for that. I hope to not spend more than 5 minutes on that. We'll see. Yeah, next slide, please. Yeah, so auto pause. The idea here is that when we switch to a new surface, the application might need some time to react to this, and it might need time to set up the new capture stream and UI and so on. For instance, if an application wants to crop the new surface, it's like an async operation to apply this crop target to the new surface, and we really would like to avoid having frames going out uncropped first for a few frames and then switch over to the cropped variant, because that is a bit glitchy and can be a privacy concern. Other applications might be if we want to split capture surface into different files, and we want to be sure that no frames end up in the wrong file. Another thing that has been raised is if we want to if an application want to ask for confirmation before switching to certain types of surfaces that might be sensitive in some way. And yeah, to support these use cases, we want to allow the application to momentarily pause the frame delivery. Next slide, please. And in this issue thread, the 2 main alternatives that we have discussed lately is to either do this at the source level, at the capture level, and say that we add a new callback to the capture controller, and we say that we can pause the capture at that level. The other alternative is to do it on the individual media stream tracks, which might be many for a certain capture. And the idea there is to kind of reuse the existing configuration change event, and primarily we're thinking of using the track enabled property to pause the frame delivery. A third option that is discussed is has been processed also as a compromise to maybe do both of these, because they have a bit different pros and cons of these methods. Next slide, please. So the capture controller callback, this will be an async function. So the idea here is that the user agent will make sure that no frames are delivered until this for the new capture surface before this, up until this function is called, and then while this actually until this has been resolved, so the application have time to maybe run some setup and then can resolve the promise here, and then the user agent will resume frame delivery for this capture. Next slide, please. And I think the main attractions with this is it's quite easy to use. I would, it's my impression at least for most applications. You have like one callback you set, and it makes it easier to coordinate. So one thing that we raised is that we have multiple tracks. We might want to like many of these things we want to do is actually on the tracks, but I would argue that it's easier to do that from one centralized function. For instance, if you have two tracks that we want to crop the same way, it's easy if you can look at the crop target once and then provide it to both these tracks rather than having this spread out over different events for different tracks. And it's also like even one promise to resolve, so it's like quite centralized and one-step solution to the thing, to the problem. Yes, next slide, please. The other alternatives that is kind of active discussion now is about using the configuration change event. So in this case, we call get split media with a new option, which is, for instance, pause on surface switching, I think was proposed. And then the user agent will pause frame delivery until this event is delivered to a certain track. So when the application gets the configuration change event, it first needs to check that this is actually a surface switching event, because the configuration change event can be different things. The proposed way to do that, the main proposal I think right now is to use a device ID, which means that we need to expose that, which is like a second thing that we need to add in this case. And when we have checked that the device ID has changed, we would set track enable to false. We do our setup and we are done. We can re-enable the track, set it to true. Yes, next slide, please. And I think the pros of this is that one pro I think is that it extends existing APIs rather than come up with some new concepts. And it also has a bit more fine-grained control of the pause state for like specific tracks when we operate, if they are spread in different threads, like if a track is in the worker, we can locally there pause as long as we need and then pause it, rather than kind of synchronize back to the main thread where the capture controller is. If tracks are only in the main thread, I don't think there is a difference between these methods, other than like how it's structured in the application. The difficulties here are, we have this need to differentiate the surface switching event from other configuration events. I don't think there's an existing mechanism for this, so we would need to, we could use the device IDs, it's like one maybe proposal for this, but this is not needs to be decided. Another issue here is that track enable false is maybe not ideal for this purpose because it produces black frames, and we often would like to only freeze the video rather than like black it out. So either there are some more hackish method to actually provide this, to actually get to this freezed state, but we might, if we want to go this way, we might want to find some better way of pausing the video track or the media tracks. And I would say also this can be a bit more difficult in an application to coordinate all these multiple events because you don't really know the order of them, but that's kind of, maybe it's a bit both pro and con. Yeah, next slide, please. And then there's a third alternative then that we just combine this. There is some discussion here about ordering if we would do this. So the idea would be, first we update the tracks because we want to have them updated so we know what we're working on. Then tasks are queued to find configuration change events, and then after that we call the callback, and at the end there we can resume frame delivery. Yeah, next slide, please. And then was at the end of my short presentation here. And yeah, so I think that we have a few main questions here. The main question is, of course, which alternative we would like to continue with here. If we want to go the callback or the event, or we actually want to do both of them. It's a compromise. And if we want to go with both approach, there are some further questions we can go to that case. But otherwise, I think, yeah, we can get started. Johan?
Yeah, if you can go back to slide 17, maybe. Yeah, before that. Anyway, let's take the example of a web applications that wants to pause and ask the user whether he actually wants to continue and reshare the content.
Yeah.
So in that case, there are two things to consider. First, you want to pause the sending of the video frames to the other parties, but you want to keep the local preview so that the user knows what is sharing. So you cannot use basically the pausing API to pause the sending, because the sending will last longer the pausing for the local preview. So you anyway need some differentiation. So that's why. Yeah. So that's one concern there.
Yeah. Do you want me to respond, or do you want to say something more before?
Yeah.
So my thinking here is that even if we have the callback, if we have the callback, we can do the same thing as we do in the case of the event. That we, in this case, we would immediately return and say that resolve the callback and say that. Sorry. First, we will use. We would set enable equal false for the track on the track that we're sending to the peer connection, or use some of the methods that we have discussed for how we pause the peer connection.
Exactly.
This is the same method. Like this, the same method can be used both for the callback and the events. And then we would immediately just hand control back to the user agent, and then. Sorry. You are breaking up quite a lot, so I have a hard time hearing.
That's what I was meaning. So maybe I will. Yeah, disabling the camera. Maybe it's better now. Yeah, that's what I was actually aiming at. Is that freezing the video might be hackish in both ways. You cannot, at least in some use cases, you cannot freeze the video at the source level, because that's not what you want. So you want only to pause the sending from a specific track to a specific thing. And there are ways, the only use case is peer connection, and you can set parameters, for instance, and inactivate the sender. You can replace track. Yonivar has an issue where replace track would not wait for the operation queue. So I think we can try to find a solution there in any case. So that's why I will in a Zoom call. So basically you have the local preview, and you have a track in a worker where you are sending you are sending to the remote party. So what you want there is to stop sending to the other party in the worker, but for the local preview you want to actually continue the flow. So in that case, having a configuration change event is if it's guaranteeing you that you get it before the new video frames, and it's really a nice API. So that, and you do not even need to if you can guarantee the order and so on, you do not even need to pause actually to ask the source to be paused. You will just say, okay, I know I'm in a worker. There's this configuration change event that fired that is telling me that there's a surface switch. So I'm no longer processing the video frames. I will wait for the user to click on some UI and get the information that I should restart sending video frames. So that's why I would be tempted to go with configuration change. I'm okay with the capture, like a callback also in addition to that. I'm a bit reluctant to the asyncness of it so far. The use case I knew of was the pause user, and clearly you do not want to pause in that case. You mentioned the crop target, which is something I didn't think about. So for this one, I don't really know I don't know whether you want to pause until the targets are cropped or not. So I'd like, because maybe this use case might convince me that we should go with an async at the source, but I'm not very clear about it yet. So that's why I would like to discuss it more. But so far I would be fine, as I said, with a callback that is not async, it's sync at the capture control level, and also the configuration change event exposing the device ID. It's pretty cheap, and it would be convenient. About the order now, I think that it would be better for the settings of the track to, when you get the callback, to reflect what's the new surface, what's the new track. And the way to do it is usually to fire the configuration change event so that the settings are updated, and then you have the callback and you have the information that, hey, this track is actually a screen or it's a window, and you have all the information you need to actually do the decision. So that's why I would select this order.
Yes, I think maybe I'll let Jan-Ivar come in now. And then yeah.
Yeah, hi. Sorry. So yeah, I've been taking some notes. So I think the UI case where we want to prompt is solvable with either API. I think it's already been mentioned. I think that the only need for async here would be for APIs that it cannot be sync, like replace track and crop to, which was mentioned. So beyond that, you would not need to. So I don't think there's a long-term impact on a local. You don't have to it's not like you have to freeze a local source because of a prompt. So I think that's solvable. Configuration change exists today, and it's mostly about adapting consumers of a track to its new properties, like if you resize a window, stuff like that. Things that might be correlated across origins and might need fuzzing in some admittedly edge cases. So to me, alternative A seems a lot simpler. And I like it because if the goal is to freeze frames and not create black frames, the switch is happening upstream in the source, and it seems conceptually simpler for web developers to gate those frames as the source before, rather than handling it downstream. And also that would not. Also, device ID is currently not specified in this case, which means that configuration change shouldn't technically even fire unless there's a change in properties that affects the consumer, like width and height or blur, for instance. And I also don't like firing events that aren't clear about their cause, because that leads, it's also mentioned that apps need to decode the reason for the event. And we all know that, maybe 90% of web developers will do that correctly. Maybe that's generous, but there'll be some that fail to consider all the causes of that event, and then that cause happens and they aren't handling it, or they're reacting when they shouldn't. So I think, but I'm open to discuss, but my preference would be one.
Yeah.
Can I just
before I let you in here, Johan, I would like to ask you, Johan, a bit about the configuration change event, because when I looked at how Chrome does, it's only for this what is it, for blurring the background, and there are very, very few cases this is actually emitted. But it sounds on you like this is a kind of an event that you send in many cases. What is your view on when the configuration event actually happens?
Now, normally, it should be fired whenever the settings are changed, and that was done out of the hand of the web application. So the driving in initial case was when the user was through the system, through the user agent or through the OS to enable blur, for instance, and then suddenly blur is changing. So there you want it. So, and it's roughly the same, like if you're changing of surface, it's out of the end of the web page. So it makes sense to also fire it there. Just to mention fuzzing, I don't think that we should fuzz. We added the note there out of to be extra careful, but I don't think fuzzing is protecting anything there. So probably we should remove the note. In the case where you're doing the work in a worker, having the callback in window is actually more painful than anything. And if you want to really control the things, then you actually need to make the callback async, then post message to worker, stop the emission, then go back to the worker, go back to window, and then re-enable. So it's not as simple as the configuration event in the worker case. So that's why there are merits with both APIs. And if we agree with device ID and with the ordering, I think that it's very cheap to support the configuration change, and it should not be and it will be useful in different ways for different applications. So that's.
I think that I think that we are all. I think if I heard you correctly, I think you and were open to having the both approach, and I think we are also open to that possibility. What are your thoughts on that, Ivar? Sorry, John.
Yeah, I'm just saying I'm okay with it. The thing I'm not sure about is whether the callback should be async. So I don't think that it should be async for two of the use cases mentioned. There's the crop target use case, which is to me is new. So I'd like us to discuss this. If it proves that it would be great to use crop to use an async callback for the use case of crop target, then we can add it. I'm reluctant to adding it by default, simply because it's adding a new state where the track is not emitting video frames, that it's not muted, it's not enabled equal false, it's something different there. So I would prefer that we would not go there. But if there's a use case for it, then yeah, why not?
So Jan-Ivar, what is your thought about the both approach?
Yeah, so I think that comes down to the other issue we're going to discuss today, which is whether screen capture should have device IDs. Because right now in the spec, they don't have device IDs, and they don't in Firefox either, which means that you wouldn't even get a configuration change event unless there were changes in resolution or anything else that required the sync to alter its processing. If we decide later today that we want the device ID, then configuration change would need to be fired, right? So it's not based on any decision that we make here on this issue.
So sorry, is this discussed in another topic issue later today in this call?
But,
that's reverse order then, okay.
Yeah. Maybe we should have done the reverse, but anyway. The device ID exposure there. One of the use cases, of course, you're in the worker and you want to check whether the surface has switched, and you can sort of do that with surface type and label, but it's not bulletproof. So having device IDs is a small addition that helps there. But we'll discuss that later. Yeah.
Yeah. Okay. So from my view, it sounds like there is a possibility that we could agree on the both approach if later discussion today falls out the right way. While it feels like if we don't go the both approach, I see it's difficult for us to agree on either alternative 1 or 2. That is my impression of the discussion at this point.
So I should add that I'm not a fan of exposing device ID.
Sorry?
I should add that for the later discussion, I will argue against exposing device ID.
Yeah. So the question then is, I think either we kind of reshuffle the agenda for today and take the device ID discussion now, so to kind of know as input to this discussion, or I see it. Or Johan and Jan-Ivar, do you see like any possibility to move forward with another option than the both option? Yeah, Dominic.
Yeah, so I think if we decide against device ID, I think it's clear that we can go with both. If we decide for it, to me it sounds reasonable to adding both, although maybe the event is sufficient. So, I mean, I guess if we don't add it, I think adding the callback is our only option, really. So maybe we should discuss it on its own merits. In particular, I wonder if UN has opposition to the callback if we don't go with device ID. And if we go with device ID, the question is whether we want both the callback and the event. So yeah, maybe it makes sense to have the device ID discussion now, because
there's a small difference because the callback may be async or sync. So that's the point where maybe if we really need an async callback, then the capture control callback is good as well on its own.
Okay.
Sorry, I also have some. I want to say I'm not really a fan of both because it just feels a bit redundant.
Yeah.
That if we, and also I'm not sure what's been proposed there. The proposal there was to either queue all the track events first, and then queue the controller event. But this can be on different threads. It can be a worker or a main thread. So, it's, but the other interpretation is that we actually want to delay until those queued events have actually executed. And I wasn't sure what was being proposed there, because if we do that, then the callback API seems a bit redundant.
Yeah, so I think that is a bit of like a more detailed discussion that we can have when we start to zoom in on one of the main options. I would be very happy if we could start kind of find that yeah, okay, this is some kind of the way we want, because it feels like when we discuss all the options, all that, like it becomes very hard to keep track of. But of course, everything is interdependent. I don't know what the best approach here is. Should we maybe have or maybe they inform each other. Maybe the device, I
think it's separate discussions.
Is the reason for it. Sorry.
I think it's orthogonal. The question is really when the callback is executed, you have the track, right? And you can call get settings, so you can have the settings like the surface type and so on. So yes. Do you prefer to get the old ones or the new ones? And
so I mean, I think that we want the new ones.
Yes, and for the new ones, normally what happens is you fire the configuration change event, and just before firing the configuration change event, you're updating the settings. So that's why it seems more logical to do that order. We can of course find ways, like we could say, okay, it's a specific case where if we're calling the callback, we will update the settings anyway. But it seems a bit hackish there. So that's why I was thinking this order makes more sense. And yeah, it will mean that you will spend like 2 or 3 tasks before. Maybe if you have like 2 tracks, then you will have 2 tasks before executing the callback. In practice, I don't think it's that big a deal. If you're already thinking about pausing, then you will use 1 or 2 video frames. Yeah, that's what pausing is about.
But I'm sorry, can I ask you what you meant there when you say 2 tasks isn't a lot of time? Do you mean executing those tasks or simply queuing them?
So if you have 2 tracks, you have 2 events. And if we are saying that we will execute the event listeners of these 2 events before calling the callback, then you have one task. They will be ordered in the same event task source, so in the same task queue. But then the first one will be a configuration event, second one configuration event, and third one will be the callback. I don't think in practice that the delay introduced there is very, very meaningful. It's probably, to me, it's better to have like correct settings, the new settings available when the callback is called. It's more consistent.
Right. But then you're assuming main thread, that these tracks are on main thread, right?
Yeah, if you're in a worker, you don't have, the callback is executed in a different thread. So you don't have to fire the configuration change even in the worker before actually scheduling a task to execute the callback in the window. It's different task queues, it's different environments, so it's not observable. So there's no synchronization needed there.
Got it. Yeah.
Yeah.
So is there consensus that if like we would fire the configuration change event before the callback, or is it too early to decide?
So I think that yeah, my main so one reason to have the callback before that I see is that we can then know that there are switching surfaces if we do not use the device IDs as a way to know that. So it's I think that, and it's also a bit of a logical order that you get to know that EVS changes surface beforehand.
Sorry, I do kind of think we need to have the device ID discussion, because device ID is really about whether we consider the ultimate source, in the sense of the source switching, as part of the settings of the track or not.
Yeah.
Because right now it isn't.
Just to say that if you have a surface switching of a window to another window, the label is changing, so you could fire the configuration change. Even if you're going from screen to window or window from tab, then the settings are also changing, so it would fire as well there.
The label is not part of settings.
Sure. Yeah, it's but let's say window to screen, for instance. So now you get the settings, you get the surface type, and it will be either the old or the new one, and you probably want the new one there. And the configuration change event would fire in that case.
I think that the configuration change is something that we also, I don't know, I couldn't find any spec for that, what it actually means, as well, only that if the configuration changes in a very vague words in the spec. And currently Chrome does not do this. We could, of course, change this, but currently Chrome does not change sending configuration change events when, for instance, switching between if for instance the resolution changes or something like that.
So, we've dropped the queue, I guess, but I think there's an algorithm there that says the track's capabilities and settings, which I think refers to media track capabilities and media track settings.
Yeah,
it's in capture extensions spec, I think.
Yeah.
Okay. Oh, so we go to should we go to the device ID discussion? Is that I think that is important for this to kind of move forward.
That works for me, if it's okay with the other chairs.
Yeah, works for me too.
So it's slide 33, Bernard.
Okay. So yeah, the spec is saying that screen capture media stream tracks do not have device IDs, and Chrome and Safari are exposing device IDs. They're tied to a surface. I played a little bit, so if you select a different surface, then it will change. I think in Chrome it's like ephemeral. Like if you reload the page, then the device ID will of the same surface will change. So yeah, and Firefox is not, and the spec is not. So we are inconsistent there. And Yeah, there are use cases for device IDs. The main use case for exposing device IDs to screen captures is to be able to identify, so via configuration event, the change of the captured surface. But more generally, if we expose device ID there, it means that a captured application will be able to know whether a track is capturing the same surface as another. So, for instance, if we are doing like media film track processor recording, then we could use configure change event to be able to say, oh, there's a surface switch event, so it's a nice event there. So we would be able to chapterize the surface change at the video frame level. So that's one thing that is doable. You would need to set max buffered frames to 1, and you would need to understand what a micro task is, but it's still doable. The other cases is that web pages can call get display media several times, so they can identify then whether an ongoing capture is actually the same surface as an old one. So it might be also useful there. Web applications can already do that with basically labels, but it's not bulletproof. So it would be it's a small addition. There's not really any main drawback that I know of. Next slide. So the proposal there is to expose it, which would basically make Chrome and Safari compliant. Device ID value lifetime would be tied to the capturing document, like media screen track group ID. So there's no privacy implication. You reload the page, it's new device IDs. And yeah, that's it. So the use case is not big, it's true, but the complexity is very small as well. And there are like almost no drawbacks that I know of. Thoughts?
So yeah, so I think my main concern with reusing device ID here is that it's not really a device ID the way device ID has been specified in for any other source or for camera, microphone, or screen or speakers. There's no, and you mentioned here it would be more like a group ID, but it's also device ID. It's an inherent property of the device, of the source, in all the other specs. And here it would really be a sort of a new thing in source ID. Well,
Not really.
Source of the source, right?
No, the source is the same. Like if you track a clone, the source is the same. You switch off the captured surface, the clone will follow. So it's still the same source, the same, like the device ID is in that case is identifying the source, and in the camera case, it's identifying the source and the device behind it.
But the device ID of a camera never changes. For instance, if you're on a cell phone, it's not like we had this with facing mode too. Like, could this be one physical device? It's front facing and back facing one device, or are they two? And we decided they were two, which means that device ID never changes, except here, where something you've already acquired will change. Its ID, device ID, will change depending on what the ultimate source behind that source is. So it's slightly different. In any case, but more pragmatically, I think the use case you mentioned with chapterizing, I think would be better done with label maybe, because I added some comments. I don't know if I want to go too deeply into it. You didn't mention it as a big use case here. So, but if you want to chapterize based on this, that seems like a bit of an odd use case. That makes a lot of assumptions about how someone would go about doing that, opening different screens and windows of the same size to make a pleasing recording. I could see if you use tab capture, maybe you could do something like this, because all the tabs in the same window would have the same dimensions. So you could probably do something like this. But even then, it's unclear to me that you would only want to chapterize when you're switching capture, and it assumes the user would use that. So if whenever I switch to a new tab, to capturing a new tab, it would create a chapter. But if I navigate to a new website in an existing tab, it wouldn't chapterize. So I'm not sure that's the best way to solve that use case. So I think the main use case here is whether we want to use it for configuration change or not. I'd like to hear what other people think.
Yes, I'm like you. So, well, I think device ID as identifying the source ID makes sense. And for the cameras, they don't change because we decided that we don't want to change the camera for a camera track. But for because also it doesn't make that much sense to do that. But for screen capture, yeah, there's a very clear use case of changing the source. And device ID would be, I mean, maybe it should have been called source ID, but we called it device ID. So, but the concept is identifying the source, and we do allow to change it. So and you already have two implementations that expose it because the spec was probably not clear before about not exposing it for screen capture tracks. So I think it's a good idea to allow it, and if you're exposing it, then use the configuration change event to signal that the source did change.
Yes.
Any other opinions? Don?
Yeah, I personally also think it makes sense from a model perspective to expose its change. I mean, I will confess that I have a slight dislike for configuration change because it's feel a bit of a kitchen sink type of unit. But that's already something we've decided, and if we assume that developers already take care of distinguishing the various causes for it, and we might as well bite the bullet and use it in the context of device ID as well.
So I think in that case, it sounds like I have a minority opinion. So, and I don't see any particular privacy implications here. So I don't think, so I would rather not implement device ID, but I don't have a strong, I don't see a strong reason to object to it.
Okay.
So with that, maybe we could jump back to the original discussion.
Yes. That's good. So, okay, so if I have tracked this correctly, I think the only thing that was left before deciding on the both approach was
sorry to interrupt,
Sorry?
but for the purpose of the minute, should I record that we have consensus to add device ID to settings for?
Yes, I think so.
Yeah, that works for me.
Okay, thanks.
And maybe can you give me an action to check what other sources, other tracks are doing as well, like peer connection, Canvas. We should look at that and see what they're doing.
Yeah. So I think that if we go back one or two slides, I think that I would like to just kind of wrap this up. So to discussion one. Response there, this 2 steps there, yes. Okay, so I think that then so you had some concerns about the async callback, and I think that you also thought that maybe the region capture thing was something that would compel you to think that this was a good idea. Is there anything more I can say about that that would kind of help you in that to understand that better? That use case.
Maybe I missed it on the GitHub discussions, but I'm not sure it was mentioned. So yeah, I like to hear exactly what it means. For instance, is it like you're in a video conference, you're using crop target, and then there's a surface switch, so you want to pause both the local preview and the remote sending until you know whether you will crop again and so on, or is it something else?
Yes. So for instance,
that's what I would like to understand.
Yeah. So for instance, there is some variation of like to take if you have like a slides presentation ongoing, and you might have some view elements around your slide, and if you switch tab to capture your own tab where this slide presentation is, you might want to crop to the slides only and not have the UI included. And the way we do that is then we call crop to that element, and when that is done, I mean, this is an async function, so it doesn't happen synchronously immediately. You need to wait for this prompt to resolve before this cropping has happened. And we would like to avoid sending out frames with all the UI elements around the slide. Is that so we would like to, and so it's very convenient with this async function because we can just await the crop to finish and then return from. Does that answer your question?
And so in that use case, there's no local preview. There's just one track that is being sent to the remote end.
Yes.
Okay. So in that case, why not using the same method, like setting enables to false or calling replace track to null and so on?
So I mean, this was this particular example where it's only one because I took the simplest I could come up with, so I think that for me it's more about maybe a preference thing that we would like to have the logic centralized, and if you have instead another case where you might only both have a local preview of what you're capturing and transmit this cropped target to remotely, then you would have two tracks that you want to crop, and you want to crop to the same target. It's using the callback. You have that all centralized in one callback. It's you can find the crop target, you can apply it to those tracks, and then return. It seems much more complicated to align these two configuration change callbacks as events and find the crop target, communicate that between them, and update the tracks. So it's more I think an ergonomy case than actually what is possible to do.
So I should probably chime in and say that since I lost on device ID, I'm a fan of simplicity. So I'm not really a fan of both. So if we're going to have device ID, that means that configuration event will fire reliably whenever a source switches. So I would think I would prefer to only have one API for this. And in that case, it seems like only firing configuration change and using track enabled, like Ewan suggested, would solve all the use cases as far as I can tell. And so I don't see, so I think I would rather go with that then.
Okay.
For simplicity's sake. Unless there's a case that doesn't work. And I guess, so you would set track enabled false, then do the crop targets, and maybe do some replace tracking to get rid of the black frames.
Yeah.
And wait for, and then later turn track enable on true after crop target has been set correctly. And would that work?
Sorry, what did you say about the black frame? I missed that part.
Well, I understand there's a replace track trick to avoid the black frame. I forget exactly what it works.
Yeah.
But websites would do that and then wait for the crop to complete, and then turn the track enabled on back to true.
Mm.
Would that solve all the use cases?
I think so. Did you want to say something, Guido?
Yeah, what I want to say was that, well, I think it does solve that particular one. So I think we can say that since we have consensus on the device ID, on the configuration change, we can start with that and continue to evaluate the use cases. Since like having both is, I mean, it's having both, but they're not tightly coupled. So they're orthogonal. So we can say that we go with the configuration change first. Look into all the use cases, and if it solves all the use cases reasonably well, stick with only that one. But if there is one case where having the callback in the controller, that's a much better way to solve it, then we can revisit it.
That sounds good to me.
So shall we call this a tentative consensus or a real consensus?
But we have the consensus on the device ID and configuration change. So we have that, and we put the callback on hold, pending.
Yes,
it's actually needed for some use cases.
Okay. Yeah, I think we are a bit over time, but I don't know if we have time. I can take the cross-type surface switching last if you want to have other things on the agenda that we.
Okay, we can do that one when we were supposed to do the device ID, which was late. So.
Okay. Should we do it now or later? Later.
I don't know. What do you think, Janiva and Bernard? Should we continue that? I'm the next one. I'm fine.
I think we can do it now because the agenda isn't that packed.
Yeah.
But
Okay.
probably should time limit it, maybe, what, 10 minutes?
Yeah. Yes. So this the thing is, so this cross-type surface switching is to allow to allow user agent to switch between different types of surfaces, like from a window to a tab or from a tab to a screen, etc. And that, I guess, that could be done without any API changes, really. But the thing is that there are applications that are that kind of relies on this not changing. Some applications have like may have informational text about what the kind of thing that they are sharing, or it can be applications that absolutely not want to share screens, that want to kind of stop the things that if a user shows a screen, and so this is kind of a way to. So I think here is to add a cross-type surface switching option that would, if it's enabled, then the application has said that, yeah, I'm fine with doing cross-type surface switching. Otherwise, I'm not. Otherwise, we don't know. The idea would be to start with this as default disabled, and when application writers have had a chance to update their applications, we could maybe switch this option over to have it include by default, and eventually maybe remove it. And this is more of a hint than like a strict requirement on the user agent. That's the idea. Yeah, Janiva?
So what is the use case other than backwards compatibility for an application not allowing cross-type surface switching?
So so things that I know of is that there are applications. I mean, there are applications that absolutely do not want to share the whole screen. The way they currently accomplish that is by if the user chooses a screen in the picker, they will just abort the capture, and this would be a loophole if you introduce cross-type surface switching, that will be a loophole which breaks these applications, which I believe is problematic.
It would break existing applications.
Sorry?
Right. You're saying it would break existing applications?
Yes.
Right, but there's no use case other than that, right?
No.
So
I mean,
well,
if it was not for that, I mean, we could just start adding this adding this functionality to the browser, not
Right.
care about applications.
So I think my preference would be to not add a new API, even if it's to the web platform forever to handle that case. It seems to me like a short-term backwards compatibility issue for browsers who have already implemented. So this doesn't seem that necessary to me. It also feels a bit like a doctor it hurts if I do this problem, in that for this to be a problem, the end user actually has to pick something that they wanted to use, and then they're told, oh, you can't do that. And in that case, they'll hopefully learn that and not repeat that mistake for that affected applications for a short while. So it doesn't seem that bad.
Yes, it's also about applications like being confused by what they are sharing. For instance, some functionality like we also have capture surface controls, for instance, where that is only supported for tabs. If suddenly the user agent changes surface types under the feet of the application, it might not understand that we need to update our UI.
But that's also true with any kind of. But that's also true with any kind of surface switching today, right? Applications may not expect it.
Yes, but within the same surface, I think we do a reasonably good job of actually maintaining that functionality working.
But what would break specifically? Like if it's a different window size or type?
No, but if you switch from a tab to a window, we can no longer crop. We can no longer.
There's the cropping. Okay.
Yeah, so we can no longer use capture surface control.
But then, so the crop to would fail.
Yeah,
then,
I think.
But isn't that what you want?
Because
you can't crop a window.
Yeah.
I see you and on the case. So. Oh.
Yeah.
I'll pause.
Yeah, I would look at what OS APIs are doing. For instance, if the OS is allowing like in macOS, it's really the OS that is controlling the picker UI so that you can switch the switch UI. It's not in the hands of the user agent. I didn't have time to look at whether the user agent could use an option to switch off this UI or to switch it on. If it's available there, I guess it would be fine to expose it also in web pages, because there might be some use cases. But if it's not feasible, meaning that even though the web page does not want it, it will be exposed to the user because it's the OS that decides it, then it's not really implementable. So in that case, I would be a bit reluctant.
So if we talk specifically about Mac APIs for this new picker experience, then that exposes option to if you only want to select a window or only select a screen, or if you want to be able to add new windows and so on. There are a number of options that you can specify there.
To control the switching, you mean? Yes.
Yes, you can either allow switching or not disallow switching completely.
Okay. So in that case, yeah, maybe. At least I'm not opposed. I would need to think more about it. Yeah. But if it's implementable, then maybe it's not. Yeah, maybe. Yeah. I mean, if it was exposed as a native API, it probably means that native applications find it useful. So I'm not sure why web pages would not find it useful as well. It should definitely be a hint, though. The user agent should be able to do what it thinks is better for the user. And for the default value, I would not set it to exclude as a default, because it would break existing application like Safari, for instance. So yeah, I would tend to use include as the default.
Yeah. So what I hear here, for Janiva's part, I should come up with more believable examples or strong examples. And for Joanne, I think, yeah, there are some nuances here that I should come back about.
Well, I might say it differently. If this is mostly about backwards compatibility for a specific browser engine, maybe one option is to not standardize it, because I don't see why Firefox would implement or need to implement this piece, especially since it's a hint. If it's a hint already, then simply ignoring it seems like it would be a valid implementation of it.
Yes.
So maybe it doesn't need standardization.
Interesting. Yeah.
We have had such attributes in the past. I mean, the Plan B transition was aided by an attribute that was specified but not standardized.
And where was it specified? It was in a specific repo, or was it owned by WEBRTC working group?
I think it was proposed to the WebRTC working group, but rejected as Chrome as a Chrome only thing, and then we documented it on the web page until it was gone. It didn't last very long, luckily.
Yeah.
Well, some years.
So maybe that's an option that we can discuss after the meeting.
Yeah.
So I think that we can close the discussion on this issue now.
Yeah. So, do we have a consensus that and the end state we want to get to is that cross-type surface switching is allowed, and there's no way to turn it off?
Yes, that's my my intention. And I mean, there are other with this configuration change. There will be other ways for the applications to do these things when the application writers knew about it. So there will be ways for applications to handle this eventually.
It's good if we have consensus on where we want to end up. Makes life much simpler.
Yeah, I can try to talk internally. Tove, if you can send me the link to the macOS API.
Yes.
I can look at it and see which use cases we have there for this macOS API, and whether that's relevant to web pages as well.
Can we move on to the next item?
Yes, I think so.
Yep.
Okay, Guido.
Okay, so going to talk about timing info for encoded frames. So at the moment, RTC encoded audio frame metadata, and video frame metadata contain the RTP timestamp. So it's been there since the beginning. And we have consensus on adding capture timestamp to both of them. And we have a PR that is like almost ready to land, just waiting for the absolute capture timestamp header extension to be formally adopted by the IETF. But once we have a URL, proper URL to put in the PR, we should have it there. So next. On the raw frame side, we are proposing the RTP timestamp, the capture timestamp, and also a receive time. The naming is just derived from request video frame callback, which was the first API to define these fields. So we made, so we wanted to add this to video frame metadata so that it's available in media capture transform. And so we sent a PR there, and the feedback was that we needed to properly define those things, which we have already done in media capture extensions. So we are just waiting for final approval in the media working group for these fields, which will be discussed today later. Also, we would like it for audio, except that there is no audio data metadata. So initially we went only with video for raw frames, but yeah, the suggestion of Bernard, I filed an issue to also add metadata. Yeah, we go with capture time. Yes, that's yeah. I think it's broken there in the slide. I think it's capture time. I have to double check, but the idea is to have the same name for all of them. Yep. And yeah, so the proposal is here is to also add the receive time to the encoded frames, so that we have everything in all places. So in raw frames, encoded frames, and request video frame callback. So, so it's basically it. The next slide. We would just basically add a DOM high resolution timestamp receive time to those metadata, and that's it. Yuan.
Maybe we could use like I think we can use derivation of dictionaries so that we'd have like a base dictionary, and so that receive time would only be specified in one place.
Yes. We can. The details can be sorting out those details can be the next step. So the question here is there anyone opposed to adding the receive time to also encode the frames? If not, I think the next step is sorting out those details. Jennifer?
Sorry, could you briefly describe receive time?
Receive time, we defined it as the timestamp of the last packet that that was necessary to build the video frame once you received it.
Okay.
So basically it tells you, okay, this is the time when you got everything you need to start processing that frame, to start decoding it and doing things with it. So basically, when you finish receiving the frame, when you finish receiving the encoded frame.
Receiving it from where?
For a remote frame, for receiving it from the peer connection. So you were receiving packets, right. And then when you got the last packet for that video frame.
So if I receive it and then I send it to a third peer, the receive time would be updated to be when the third peer, the final peer, receives it.
Yes.
And
exactly.
And for local,
time when that peer received it. Yeah.
And what if this was encoded by web codecs and not received? Or sorry, are there cases where this could be encoded?
No, that would make no difference. This is just reception of the receive time.
Okay.
So it's indifferent.
I'm just wondering if there's some encoding cases that aren't remote.
Yeah. How it was encoded remotely, I mean, it's up to. That's indifferent.
Well, it's more that transmission is assumed here, but maybe that's fine.
Yeah. And the use case here is so that you can measure, as I say, if you want to use web codecs to decode it or have something custom, then you know that you have a timestamp when you received it, so you can start measuring the time it took to do everything.
But let's say I have an RTC encoded source, for example, that comes from, say, web codecs. What would be the receive time?
Yeah, the receive time is the receive time once you received it. So it doesn't matter if it was. I mean, the encoded source would be on the remote side. So.
Right, but I guess there are use cases where there's no remote side, like web codecs into an RTC encoded source, for instance. It's a detail.
Once you see it in the receiver.
Hmm.
So once the receiver received it, yeah.
Okay, thanks.
So it seems logical that things that are not received don't have a receive time.
Exactly. Bernard?
Yeah, I think this is a good proposal, and I particularly like the idea of having it in both web codecs and in encoded frames. I think that's pretty important that it be in both, and because we could want to do lip sync with web codecs stuff as well as with WebRTC.
I'm not very clear about web codecs, but yeah, well, we might be able to discuss that on GitHub, on GitHub web codec then.
So can we record that we have consensus on adding these fields to the code and metadata?
Are there any objections?
Good.
Okay.
That's it.
Okay, we're back on track.
Okay, I guess I'm up. So let's see here. So we have some issues to discuss here across some different specs. So we'll jump into the first one, which is 3014. This was left over from last month. So the specs right now says to send black frames for ended tracks. If a track is ended or if the track's output is disabled, i.e. the track is disabled and or muted, the RTP sender must send black frames video and must not send audio. In the case of video, the sender should send 1 black frame per second. If track is null, however, then the sender does not send. It seems pretty clear that if you stop your local track that you're sending, then the sender should send black frames. But no browser is doing this. And there's a fiddle here if you want to try it. And I also have some screenshots here of different browsers. And excuse me. Surprisingly, there's a variant on the left side, which is actually not what we're talking about today, which is the local track. But on the remote side, which is on the right, we see that none of the browsers are sending a black frame when you end it, when you stop the local track outside of peer connections. So this is a little surprising, perhaps, and also a little illogical, because since the video on the left is technically the source of the video on the right, I would have expected as a viewer naively that stopping it to affect them the same. So you would see the same on left and right. Remote participants seeing a still of the user while the user's self-view is blacked out also seems surprising in a privacy way. However, that being said, transmitted frames are not guaranteed to be received and decoded. So if you have a lossy network and we were to mandate black frames, that the last frame should be black, if the receiver does not receive that last frame, you might still see it still. Bit of an edge case in practice, perhaps. But there was a comment that quality web applications therefore should robustly treat this edge case where the black frame does not arrive and handle that anyway. And that might remove the need for having a black frame in that case. And I think that's the only slide for this one. So discuss. Ewan?
Yes, so I would tend to align the spec with what implementations are doing. It might not be the best, but it's the current status, and web applications are still happy. So that's probably fine as is. And it would make sense to file an issue for the left as well, because we have like 3 different interpretations. And yeah, I'd like to know what the spec is saying, or whether the spec is saying anything there, because that certainly is not super great either. So it would be good to be able to be consistent there.
Okay, yeah, I can file an issue on that. And I'm not sure why. Yeah, I won't go into. I was curious why one frame is black and one is white, but maybe it's transparent or something. Anyway,
Probably
not
it's
for this
empty. Yeah.
meeting.
Maybe it says
Does anyone object to this outcome? Okay, that was quick. I think we can record the agreement to do a PR to change this to align with implementations. Right, next slide. All right, so this is an issue on media capture extensions. And here, the proposal is to reduce the scope of media stream track transfer to dedicated worker for now. To match implementations that exist, or one implementation in this case. So the media stream track WebIDL currently reads that media stream track is exposed in window and worker, where worker is short for any kind of worker, which in practice means dedicated worker, shared worker, and service worker, at least. I think that's all of them. While use cases exist for dedicated worker, which is media capture transform, there are currently none outside of that. And there also are no implementations of anything else. As far as I know, Safari 18 only implements transfer to a dedicated worker, and you can correct me if I'm wrong there. But this is also what Firefox plans to implement. And there's also been some expression of difficulty with implementing transfer. So reducing the scope for now seems reasonable because we can always extend it later once a need surfaces. So the proposal is to only expose this to window and dedicated worker. Thoughts? Ewan?
Yes. So the video frame object is only exposed in window and dedicated worker. Media stream track processor as well. So it kind of makes sense to reduce it to dedicated worker as well. Safari is only implementing transfer to dedicated worker in the same agent cluster. So, but I don't think Web Codex is spelling this out as well. And I think like in Chrome and Safari, maybe Firefox as well, video frame is transferable in the same cluster, but not anything else currently. We could spell it out. I'm not sure whether we want to do that or not, but that's something we could discuss.
Yeah, I don't have a problem with that. I guess we should try to look for any precedent for how to do that. But either way, it shouldn't stand in the way of this change, I think. So we can take the first step here and then discuss ways to limit it further to user agent cluster if that's a way. If there's a way to do that in the spec. I'm happy if people have examples that they can point to, so we could probably consider that here as well. Any objection to this language? I'm not hearing anyone, so then sounds like we have general agreement to do a PR for this. Thank you.
Go for it.
Great. The next slide is not mine. I think someone else.
Yeah, it's me.
Okay.
So it's about synchronization in the case of between media stream track and media stream track processor. So before media stream track processor, we had media stream track, which was living in window environment, and there was media content flowing somewhere else, and there was no possibility of synchronization between the two. So there were no issues. Now that we have media stream track processor, we deliver video frame in a worker, and we have media stream track in the same worker. So the question is, what happens there? Like if a track is muted, there will be an event. There will be an unmute event that will fire at a very specific point in the worker context. At the same time, there will be, or there might be, task to enqueue video frames. And this might happen before or after this event. It's not really clear. The spec is not really saying anything there. So the general question is, should there be requirements to synchronize MediaStream track states, events, and the enqueuing of video frame in MediaStream track processor? Because all these things, basically what they're doing is enqueue a task in worker context to either change settings and fire an event, or to enqueue a video frame in the MediaStream track processor readable. Next slide. So I listed some cases there. So for instance, we have the mute and mute events, and depending on the synchronization, we could get events. We could get video frames being enqueued after the mute events fires, which is probably unfortunate, but maybe web applications can live with it. At the same time, we could allow enqueuing video frames before the unmute event fires. And that might be a bigger issue, because then you might forget to call read, and the video frame might be dropped. While if you were able to know that the unmute event was firing, then you would have called read directly from there. So there are some things there. There's a configuration change event. Say if the device ID is changing, for instance, should we allow enqueuing frames of the new device ID before this event is firing? So that's another thing. There's the apply constraints promise resolution. So the promise is being resolved at a specific time in the worker. And again, should we allow enqueuing of video frames of the new configuration before the promise is resolved or not? That's something we could find. We need to decide. And more generally, if you're using get settings and video frames, if they are not in sync, if the MediaStream track settings are not in sync with the last enqueued video frame, then some data like exposure time, width, and height, and so on would not be aligned with the video frames that you end up getting. And in general, maybe that's fine, but it might be a foot gun as well. So I'm wondering what the working group is thinking there, and what we should do in general. I don't have a specific proposal there, but I like the spec to be more clear about what we are doing. So I see people on the queue. Bernard, you're first.
Yeah, I want to speak to the last one, which is I would suggest that we not try to synchronize get settings and video frame properties, but just have the properties derivable from the video frame itself, if possible.
So that would mean that we would replicate all the settings that we expose in the video frame metadata, basically, like exposure time, color, temperature, ISO.
Maybe not all of them, because the ones that aren't relevant to the video frame itself, like the facing mode, I don't know that I would try to replicate.
Right.
Things like, whether background blur is enabled, we already are talking about putting that on the video frame, and the width and height and stuff. And so, yeah. Anyway, that's all I wanted to comment on.
Okay. Univar, you're next.
Yeah, it sounds like we have two questions here. One is the timing of this, but also whether we should add to video frame metadata. I think that's a separate issue. I won't comment so much on that. But I think that it's good to specify things, but I don't think that we can. I think it would be a mistake to try to think we can provide meaningful synchronous guarantees. MediaStream track processor has a buffer, defaults to 1, but there's a settable max buffer size. So, and also readable streams, I think there are some expectations around the use of readable streams that might be good to not. I'm a little bit worried that if we couple things too tightly here, I worry that JavaScript won't be able to add a transform into a pipe without breaking things or expectations. So it'd be nice to see some examples of existing implementations, to see what are the guarantees today, which ones are problematic. For instance, allowing enqueuing, being able to receive a frame after the mute event has fired might be unavoidable if there's a buffer, for example. But on the other hand, I think we can expect that the unmute event has to fire before you see the video frame. That makes sense, right? So unless you just toggled it on and off. Again,
so I'm specifically talking about enqueuing frames in the readable stream or in media stream track processor. I'm not talking about reading video frames in the readable stream. If you enqueue a video frame in the readable stream, it means that you will get it in the next event task, albeit maybe not in the event task like at the end, because it will be queued as a micro task. So in the micro task queue, you will finally get all of them. So you can empty the buffer there without any issue in the current event task. So that's why I'm very specific about enqueuing within media stream track processor, which we are entering a task. So we have a new video frame, we are entering a task to actually do something. And that's where we can actually synchronize things or not. If we are trying to synchronize unmute, I think we should also synchronize mute. It's less interesting, but it seems like to be it seems to be meaningful. Like you will enqueue video frames, and then you will enqueue the mute event, and then you have like the guarantees of synchronization that we can specify. And similarly for unmute, you will enqueue in the same task queue the event, and then we will start enqueuing new video frames. And we can try to precise words, like to give us advices and make it clear in the spec with that regards. I kind of agree with get settings with Bernard as well. I'm less sure about configuration change event and apply constraints. But I think it would be useful for the configuration change even for the device ID, for instance, that you would enqueue the task to fire the configuration change before enqueuing task to enqueue video frames there. And it will probably happen naturally, except if you have like different pipelines.
But how is this observable in the sense that how are you going to handle max buffer size 10, for example?
For max buffer size 10, I do not see how it's an issue actually, because you will read and maybe you will have 10 video frames and you will be able to read 10 video frames in the task, but in the next event task, you will not be able to read anything. That's the point. Yeah. Harold, or maybe Guido, I don't know.
Yeah, what I'm saying is, why do we need to do anything specific? I think my point is that the language should be about what it should do with sinks. This is just one sink, and then I think the buffers and all that is already part of the sink.
Right.
So if something is buffered and you start reading from it, yeah, you will read something even if the track is muted. But I think if anything, we should say something about sinks if we are not saying it already, and that's it. But having something specific for media stream track processor, I mean, most of things that happen in media stream track processor are outside the track because it's just part of implementation of the sink. So it's no different from what we would do if we could do this with per connection or video element or anything like that. So, I'd say that that.
So one model that we could consider is that video frame sending and events like mute and unmute, they are always sent in the same thread. So the sync is receiving them in the same thread. And then we enqueue task in window for the mute events, and video frames, they stay where they are. And if there's a place where we are sending the video frames and the events in the same thread, like worker, media stream track processor, and so on, then they will be naturally synced as well, because we consider the source to be single-threaded, basically. Maybe that's the model we want. Harald, you're next.
Yeah, so I agree with Guido that we should up-level this, because video frames are perfectly observable on an HTML video element too. So I mean, having we can probably not observe if it goes right, but we can observe if it goes wrong. If we get the video element and then get a frame that if we get a mute event and then get a frame that was clearly by its timestamps, I don't know, sent after the mute event, that's an error. And I think we should call it an error. So yes, I think we should have synchronization. I don't think the buffer thing is any problem at all. It's just about the timestamps on the. I mean, things in the buffer will be buffered, but they have to enter the buffer before the mute event fires. So I think we should synchronize, and I think we should say what happens. UN's description I don't like much because it is too constraining on implementations.
It's just a model. It's just a model, and then you can implement basically this way. But it would mean that you have a mute event, and then there's no video frame sent to the sync, and the mute event and the video frames will be somehow sent synchronized. So single-threaded is, of course, way simpler to explain there, even though it's not the case in practice.
So we can say something like the events, the observation of the events have to act as if they were ordered. As if they came from the same event source. I'm not sure what the proper language there is.
Yes, I think also. I think I would like to see more why this is a problem, and more. So I'm not opposed to filing issues to look at this more specifically, but maybe describe as something that is problematic today, because I think focusing on the event might be a mistake, because the muting happens in the background by the user agent in most cases, and so the event gets queued on the main thread, and that happens later. So there's a delay here before things are observable in JavaScript. So I agree that making sure that the ordering is okay should hopefully fall out naturally in many cases. There is, of course, if you have a video track generator on the other on upstream, you can probably write a web platform test that mutes the video track generator. In which case, I think it currently, last I checked, it waits until it lets the task run to completion, and then it basically queues a task to queue a task, I think, on each track. So I don't think, the only thing I'm worried about is making two things too synchronous, because I don't think we can provide necessarily guarantees in all cases. But obviously, if apply constraints sends new settings and you get if you get new video frames before apply constraints have resolved, that might be an issue, for instance. So I think we have to go, but I'm not sure there's an overall solution to all of these. I think the devil's in the details.
Yeah, I think we can remove get settings and video frames, at least. and focus on the three others. And yeah, I can try to describe on GitHub some issues that I can see with the desynchronization.
This
Bernard,
includes
you're next.
tracking tables as well, right? Sorry.
Yep. Well, no, because track enable. Well, there. I would think no, because track enabled there is asynchronous. It's in the worker, and it's synchronous. So you should be. Well, I can check media capture transform. I can look at that. Yeah. Bernard, you're next.
Yeah, I wanted to talk about configuration change event and apply constraints. Are we clear about the effect of each of these events on the actual video frame properties? All the things that would actually change, and are we sure that we have all the right properties? Otherwise, I agree with Yanivar's comments about trying to be too prescriptive, but I'm just wondering if there are other video frame properties that might be desirable.
In the screen, in the surface switching for screen capture, for instance, you're in a worker. There's a configuration change that is firing, and that will tell you that it's a new device ID.
Right, but that's not a property of the video frame, right?
And it's not exposed within video frame. So the question is, let's say you call read, and you call read once because you have a buffer of 1, for instance, and you know that it's not in the readable. There's no pipe. There's no video frames in the pipe because it's feasible to know that. Then are you guaranteed that the next video frame that you read at the next event task is of the new device ID or not?
Yeah,
that's the question.
Yeah, but I guess what I'm saying is I don't want to try to make these inferences based on the event firing, the timing of that exactly. If would prefer to make it by just looking at a video frame property if I need to know it.
Okay.
I mean, we've had the same question come up, right, with background blur and lots of stuff. People want to know, is this frame, was background blur enabled or not? So that's the question I'm asking. Is there an implication for properties of the video frame? You don't have to answer it now, but I think that may be the question to ask.
Yeah, for background blur, my understanding was that it was useful mostly as a writable metadata, so that you can say, hey, I already background blurred. So that's why it was very useful. Otherwise, you could annotate your video frame with a JavaScript property yourself by looking at get settings and doing that there this way.
Right, which I think we're going to discuss in the media working group in the afternoon. Basically, these kind of custom video frame settings. I think that will be relevant to that. Okay, thanks.
Okay, I think we are clear there that I need to do some. Well, we need to discuss it more, and let's try to do that on GitHub. I'll try to add more stuff there. Not this. So next issue was already discussed. So next one is issue 147. So I think Guido filed it. Implicit consent that get user media is currently not allowing access to not mic speakers. So enumerate devices is used for several things. One of the things is to identify whether there's camera and microphone. But once you're capturing, it's also used for building device speakers. So it's used for cameras and microphones. And it's also exposing speakers for web applications that are capturing microphone, but only a subset. Chrome is not implementing that, and existing websites are implementing speaker pickers, which are like you have the microphone picker, the camera picker, and the speaker picker as well. And it would only fully work if we are exposing all the speakers. The spec, as I understand it, when last time we discussed it, I think that we were only exposing speakers that are tied to microphone to push the web towards a select audio output, which is superior approach, because it's working whether you're capturing or not. But keep the ability for a web page to ask the audio to directly go to a headset with mic, without user prompt, which is a useful scenario as well. Next slide. So I think that exposing all speakers is a small decrease of privacy. In general, we prefer user agent pickers instead of exposing all devices. But there, we expose speakers only when microphone is in use. So it's gated by prompts. And even if it's not gated by prompts, if there's persistent permission, it's gated by capture indicators as well. And if you provide the microphone, in any case, you're providing a lot of information. So exposing a few speakers is probably not that big a deal. And we have this inconsistency with camera and microphone, where you can build a picker and speakers you cannot. So the proposal I'd like to make is to allow exposures of all speakers. It's practical because we are in the current situation, and I'd like us to investigate camera and microphone usage and picker APIs as well, so that pickers implemented by the user agent would be superior to web application pickers. There are in some cases where it would clearly be superior. So it might be nice to do that, so that we would have select audio output, and we would have the same thing for camera and microphone, and we would have the legacy thing where web application would have like their own pickers in case they're capturing microphone or camera, and support speakers there. Thoughts? Yeah, Yanivar?
So my concern here is that this might be blocking on, there's another issue in media capture main, which is 1019, which I put in chat, which is questioning the purpose of requiring a successful GUM call before new devices. So until that has been resolved or closed, I do not, I don't feel I'm not ready to decide on this issue here, because it's not clear what the net effect of that would be. Because I think this might be a good idea if we could provided we maintain the specs existing requirements of a successful GUM call, because that would mean that the difference here would only be that all speakers would only be exposed when a microphone is active.
Yeah,
However,
I think that's a proposal here. Yeah.
However, updating the spec only to, but it's unclear right now with depending on how 1019 ends up. I'm not comfortable reducing, privacy here. It's going to end up reducing privacy on issue 1019 further. So these two issues seem related for me.
Okay, I see. I think that somehow you can try to disentangle them by keeping the fact that you need microphone capture to actually enumerate the speakers. And the only thing that we would remove is the fact that the speakers we are exposing are tied to a mic. It's just this small change. And hopefully that would make it orthogonal to the issue you're mentioning. And we should make progress on that issue as well. Yeah. Guido, you're on the queue.
Yeah, I want to point out that I think issue 1019 is completely orthogonal to this one. So issue 1019 is it's a more complicated one, but it's orthogonal to this one since we're already exposing speakers here. So the issue here is which speakers we expose, and not whether we're exposing speakers or not. We're already allowing exposure of speakers. Now, when we expose them, well, we in terms of when is enumeration allowed, when is it not allowed, that's a separate issue. But if it's allowed, you're allowing to expose speakers, you should expose all speakers because otherwise there are a lot of use cases that break. And I think that like which speakers to expose is orthogonal to when you're allowed to enumerate.
So Guido, do you know whether Chrome is exposing speakers even though there's no capture?
Chrome uses gates enumeration on permissions, which is what the spec said before.
Okay, and would you be willing to update for speakers to what the spec is saying, provided this relaxing, or would it be too complex to do?
No, I mean complexity. The problem is that the breaking the web. The problem is not about complexity of implementing. We implemented that forcing. Requiring it, so that's 1019. So we implemented that a few years ago when the change made it to the spec in 2020, but we broke the web. We broke the web, and so we have to roll that back. So we left all the other privacy things that came with after the thing review. So having empty IDs, the partitioning of device IDs, so storage partition and everything. But this one we had to roll back because broke a lot of use cases on the web. So so we're staying with the permission gating on permissions, which is which can be implemented with Get User Media if you simply would say that the permissions are not like implemented in the way Safari does, which is that you don't have permission persistent, so you need to call Get User Media to get the permission, and then you can enumerate only after Get User Media. So that's it. But I think the issue here is which speakers are exposed, not when to allow things to be enumerated or not.
Sure, I was just trying to understand whether 159 was specifically like the other issue was specific to camera and microphones, or whether it was also including speakers. And it seems to include speakers as well.
Include speakers, yeah, everything, yeah. All enumeration. Yeah.
Okay, so Yonivar is next.
Oh, sorry. Yes. So so this is underscoring my point, is that the two issues are connected, because any decision we make here might be implemented differently by different browsers. So
Bernard,
we should be clear that.
Sorry.
Yeah, go ahead. I'm done. Bernard?
You're muted.
Yeah, I agree with Guido that I do think that they are orthogonal, and I would like to see the implicit consent allow access to non-mic speakers. I think we're a little bit too entangled now. Thanks.
I would like to emphasize that I would object to this until 1019 has been resolved, so that we can know exactly what the privacy properties of these additional speakers would be.
Okay. So I guess we should try to discuss 1019. Would it be possible to discuss it at next interim, for instance, and try to make progress there?
Sure.
Okay. Sounds good. I think it's the end of my slides.
Okay, are there, for the notes, do we have all the action items, next steps? I guess, one next step, UN, is to add discussion of 1019 to the next agenda. We can add that to the notes. Are there any other next steps, people would like to add into the meeting minutes?
I think we had a good selection of the next steps that are probably captured. So
Okay,
with
Then
a lot of agreements, good meeting.
okay, then I think we're done for the day.
Okay.
Thank you, everybody.
Thank you. Bye-bye.
Thank you.
Have a good holiday.